name's Rohit Bakshi, and I have Abhijit here who's going to co-present with me. We're from Hortonworks, and we've been working for about the past year now on getting Apache Hadoop and the entire system of components on Windows. So we'll talk a bit about what we have and talk a bit about how it integrates with some of the tools that exist and walk through just HDP to doing business analysis through Microsoft tooling. Abhijit and myself are going to present, and what we'll do is we'll focus first on HTTP on Windows. So HTTP on Windows is, you can think of the core of the platform, all the Apache Hadoop components that you care about working on Windows, and we'll talk a bit more about that. Then building on top of that core is a lot of the end tools that an analyst or a data worker or developer would interact with. And so we'll go through some of the use cases and how you would interact with the Microsoft BI tool set that you're familiar with and enable that on HTTP on Windows on a scalable Hadoop platform. Then we'll go and showcase one of those scenarios through a demo, and I'll talk through what we're doing and how we built this, and then we'll open up the questions at the end. So HTTP for Windows, if you're not familiar with the Hortonworks data platform, it's basically us taking a bunch of the Apache components that we work with. So you start with Hadoop core at the enabling layer, the scalable stores and the scalable processing. Hive and MapReduce and the different data services. So how do you actually run queries on top of the scalable storage? How do you interact with the data in that storage? And then operational systems, so Uzi, Scoop, ways to move data in and out. So all these important Apache projects that come together to give you a comprehensive data platform that's scalable. That's what the Hortonworks data platform with all these Apache components are together. That's what we give you in HTTP. And what we've done over the past year is that all these Apache components, especially Apache Hadoop, was limited in some ways to just one platform, to Linux and Unix systems, right? That's the history, that's how it's grown up, that's how development has happened, that's how all the platform-based, how you start up services, stop services, management, all that was very Linux focused. And we said the community needs, and the business, the enterprise community wants us to expand Hadoop to work across all important platforms. And Windows is a very vital platform that is in all enterprises and powers databases, powers communication servers, powers a lot of different enterprise class systems. And so what we've done, and talk about how it's in the Apache community as well, is we brought the Apache set of components to Windows. So when we were doing this work, and we worked actually very closely with Microsoft on all the development, it was all done in the open. And it's part of extending the community sense, the hard work that goes on in the Apache community, and bringing all the work to making Windows into Apache. So if you look at the Apache Jira, you can actually find the initial Jiras for Hadoop, Core, Pig, Hive, these different components. You can look at one Jira and then look at all the work that's happened from that Jira. So it's actually really cool. We have the power of the community working across all these different components to extend the platform readiness of each component to more platforms. And so that's the work we've done. It's all in Apache, and you can go look at it if you want to right now. So what do you get with that work? What do you get with the set of Apache components, Hadoop components, and what do you get with the work that's being done in Apache? You now have the ability to deploy your scalable Hadoop platform on Windows Server. You have the ability to deploy this as part of Azure HDInsight, which was just announced for public preview. So this set of components that we have, the same components I showed you in that list above, works on all these different platforms running on Windows Server. And so what you can do as an enterprise is you can now, and then as we develop this in the future with the roadmap, take all your workloads that you have, you can deploy them first on a Windows Server kind of bare metal boxes that you set up in your data center. You can move them to the Azure cloud whenever you want to move, or either extend your processing capabilities or run some data processing in the cloud. You can bring it back down for private cloud and deployments and Hyper-V. You can do all these different things, deploying the same set of Apache Hadoop bits. So you're no longer limited by the platform choice when you look at Hadoop. If you're a Windows system administrator, if you're a Windows developer, there's a whole set of people out there that are now enabled with this technology. So just want to give you a bit of a flavor of how it looks on Windows, and probably very familiar with the services pane. Like if you're Windows administrators, you work with Windows. When we took all this and we took the different components and made them work, part of it was incorporating into how Windows manages services. So when you look at here, you can see that all these different Apache Hadoop services, the Hive server, the name node job tracker, are now all registered services on Windows. So you kind of plug into this ability to manage your services on Windows. The same kind of functionality you used to. You're not regressing. It's basically taking the entire source code, code base, functionality base, and extending it to work on Windows. So you have all your CLI, command line interfaces to Hive, Pig, Hadoop Core, loading data into HDFS, running scoop jobs. Whatever you do with Hadoop on other platforms, you can do on Windows. It'll look slightly different. You might use the CMD screen instead of the Unix bash shell, but really it's the same kind of functionality. And you will have abstractions with different applications and tools so that if you don't want to work in the CMD shell, you don't have to. But think of, you're used to working with Hadoop, you were used to working on one platform, now you can work on other platforms like Windows. And with that, I'm going to call Abhijit to come on, and he'll talk more about building on top of the HTTP core and how we now integrate with the different tool sets.
Perfect, thanks. Hey, cool. My name is Abhijit Lele. I'm a solutions engineer here at Hortonworks. And my job is to mostly help our sales team to understand customer requirements and focus on how we can deploy solutions on Hadoop, right? And for past year, we have been talking about Hadoop on Windows, and a lot of customers has asked about how we deploy Hadoop in our environment on Windows, right? Because if you look at it, 70% of the server infrastructure has Microsoft Windows in it, right? Windows Server. And with Windows Server 2012, there are a lot more enhancement that came in with file system, right? So Microsoft released REFS, Reliable File System, that has a lot of features such as deduplication, thin provisioning, clustered file system awareness. So now what's happening is they're bringing all these services into Microsoft framework or Microsoft umbrella of services. So when they look at it, customer says, okay, I have all these skill sets in my environment. And when you look at a layer on top of that, right, you see a Microsoft application frameworks. And if I ask you how many of you have worked on Microsoft Excel, I think 100% of you guys will have their hands up, right? So think of this way. So we're bringing Hadoop, or Microsoft is trying to bring these different data sources and the ability to analyze that data to the end customers, right? So bring that data and take that layer as much away as possible, because all this processing happening today in terms of ETL is sometimes hard-coded in the SQL systems, right? So you go to the customer, they'll say, oh, we wrote some custom SQL code and we're doing that on a SQL server. The problem is there's a limit how much you can do on your SQL server in terms of scalability, right? In 2005 and then 2008, Microsoft kind of put guidelines, right? So you had 250 gig databases were a norm. Now you have up to terabyte databases where they say it's good because beyond that you have problems such as indexing, scalability, and so on and so forth, right? So if you look at this framework, Hadoop becomes a +1 infrastructure on Microsoft, right? And the idea is to potentially coexist on SQL Server as well, right? And we'll see in a couple of slides what that vision looks like. But if you step back and say, okay, what are the data sources? And most of you go to an enterprise as a consulting, you'll see most of the emails are hosted on Microsoft Exchange. Email, there are only two providers, IBM or Microsoft, or email in cloud, right? So in a sense, the emails are sitting on a Microsoft infrastructure. Secondly, your internal collaboration tools, if you look at it, SharePoint is one of the largest popular collaboration tools in there. And then you have communication frameworks on the Microsoft LCS, right? And most of these things are accumulating data, if you think of it this way. And then obviously you have shared services and the documents sitting on Microsoft infrastructure in there. So we always knew that how to interact with the databases. Everybody knows SQL, so SQL Server was an integral part of it. Then came email, right? Then came SharePoint. Now it's coming, more and more, if you look at SharePoint, it's becoming like a Facebook for your enterprise. Now if you look at SharePoint GUI, you can do workflows, you can do communications, you can do file services through the same HTML5 AJAX-like interface. So this gives you an ability not only to capture that data set, but analyze those multiple data set in a singular platform. Emails, communications, file system data, and obviously the data set we're looking at from SQL Server, right? So it becomes ideally for all the customers. And in past year, what we have seen is we went to one customer who is capturing the event logs from all their servers. Not only Windows event log, but the sys logs, right? And they're putting into a custom application that's based upon a database. And in that scenario, it was SQL Server. So in the past, they couldn't go beyond few terabytes of data capture. So they used to capture this data for a month or two, process that data, and put the results somewhere for their regulatory or event-driven workflows. So what they want to do is they want to capture this data and understand when this particular event happens, we need to take X, Y, and Z steps. So they want to be proactive. So the major use case, what we have seen, is to offload SQL Server into Hadoop-like infrastructure and keep it longer term. The second thing is some of the not point of sale, but some of the remote infrastructure systems also deploy SQL servers, for example. Now, those SQL servers are still limited by the capacity and the resource utilization on those servers. So what some of the customers are thinking about putting Hadoop and SQL Server on the same Windows platform and take advantage of SQL offload and share those resources on that Windows server to take advantage of it. Because most of the times you'll see SQL servers not taking full advantage of hardware or limitation of storage, or you don't have a high performance storage available on the server, or the cost is not optimal on that site. So you can take advantage of Hadoop, or customers are trying to take advantage of Hadoop in that scenario. The last but not the least, the platform, right? So we'll go look into individual pieces here. One is infrastructure component, right? If you go into most of these enterprises, and some of you are from that enterprise or some of your consultants, everybody has some sort of Active Directory environment. And today, what's happening is most of those environments are going towards centralizing Active Directory with the newer version of 2012 or 2008 infrastructures, right? So we already have that authentication framework, as well as we can plug Hadoop Kerberos into Active Directory, right? So that exists in the customer environments. They're familiar with it. They use it every day. Their users and groups are already defined from so many years. That knowledge exists. And obviously, the workflow of authorization on the data also exists. That's great. Second is System Center is one of the most popular management tools. After they said we'll be able to manage and monitor virtual infrastructure from other hypervisors as well, right? So now it's becoming more like a de facto standard, whereas you're monitoring not only Windows system, but all other systems in your environment, okay? So we're able to use Apache Ambari's RESTful APIs to guide that monitoring and management framework in there. So tomorrow's goal is potentially deploy the system using a single click, say go deploy me Hadoop on Windows and get me 5 nodes. So it's going more dynamic deployment, management, monitoring. Not only from Hadoop perspective, but they do bare metal today. So if you have a virtual infrastructure Hyper-V, say go deploy this for me, install Hadoop services, bring it online, and tell me when it's ready. And it's inbuilt workflow. So we're enabling that through System Center. Not all the features are available today, but eventually they will be, right? So when the RESTful APIs are published for Ambari, they'll be able to take advantage of that. Data connectivity perspective, right? So we had Scoop connector always available for past 3 years or so to transfer the data between SQL Server and and Hadoop. One thing they have done is they work with SQL Server Parallel Data Warehouse. So this is Microsoft's EDW solution. So There's some more testing and configuration features. We work with them for Scoop connectors, and that's available for SQL Server and Parallel Data Warehouse as well. And I have one slide at the end that talks about what Microsoft thinking process is with Polybase, right? Last but not the least, actually Microsoft announced yesterday that HDInsight on Azure is live. It came out last night, or last night in Eastern time, whatever time frame, right? So now you can actually use Hadoop on Azure, and you can subscribe as a service, and it's fully supported. It's no longer beta. You can purchase or however you do it on Azure. The other benefit, what they offer is Azure Data Market. So what Microsoft is trying to do, or actually they have it, they have thousands of data sources where these custom resource organizations put their data set, right? One prime example being a pharmaceutical company is trying to purchase the data on lung cancer research. And they collect this data from the CRO, put it in Azure, process that data against their research, and feed the results back into their infrastructure. So it's not a sensitive data because it's already anonymized from the research organization, and it's available for you at a price, or some data sets are obviously free. ODBC drivers. So we have ODBC drivers available for free download, not only from us, but also from Microsoft. And they have a couple more features. And one of the features we'll talk about is in Excel. So the Hive pane, which is enabled in Excel 2013. So here's the beauty of it, right? So Excel now capable of running Hive queries directly through an interface that user already knows. And oh, by the way, with Hive Server 2, which is we ship, and what Rohit talked about, has a Hive Server 2 with authentication enabled. So if you Kerberise and connect to Active Directory, you know Rohit is running that query, and only Rohit has access to that particular data set. When you install the ODBC connector, it gives you an option to install Hive plugin, or sorry, Hive pane plugin. So you can select that, and it'll install it for you, right? And you can obviously create, extract this data set, and push that and publish it into SharePoint. So a customer is trying to bring that data, create this plugin, and push that into SharePoint. That obviously works. The second thing is you can do, if the slide moves, okay. This obviously you can customize what query you want to do. So it's fairly standard parameters on how you build HiveQL, right? And it's essentially a visual representation. And at the end, you can create your own custom query. So you can write your own HiveQL, or when you obviously change criteria that I want to select X, Y, and Z column, it'll build HiveQL for you, right? And if you don't like it, you want to basically do some certain other things, you can do that. This will run a MapReduce job. Obviously, it's a Hive query, so it's a SQL connectivity, and then bring that back into the results back into Excel. It's running on Microsoft ODBC driver, or you can use Hortonworks ODBC driver, or I would say open source ODBC driver for that purpose. The PowerView. So once you get these data sets back, as an end user, there are a lot more feature sets that are available in Excel 2013. So it's more like a hybrid of what Tableau does. It's now freely available to all the customers who can use Excel, right? You can use geographic mapping to your data set if you're connected on the internet, obviously. There's no live download of geographical data yet on Microsoft, but you can bring that data set and basically use tools like Mahout. You can make those decisions if you want it. But now the visual tool is available directly through Excel, right? And there are other charts you can build. Obviously, I'm not that expert in Excel, but geographical thing was really easy, right, to do. So beautiful charts, beautiful UI. Okay, so the next step of the process is we know that Hive is, until we bring Stinger to its life, to its full extent, right? We know Hive is not capable of running real-time queries to a large set of data. So there's one customer that Microsoft worked with and published a paper, and the link is, I put it there, which is SQL Server Analytics Services with Hive. And you can bring this cost-efficient OLAP and big data mining functionality together, right? You're taking this big data, mining it into Hive, and make it available to SQL Server Analytics Services to build your cubes, do an ad hoc query, create dashboards, create beautiful dashboards on the fly on a rich GUI, right? So you can also do a pass-through queries, right? So you can do the semantic layers on SQL Server Analytics Services, but do the pass-through queries through SQL Server or existing infrastructure you have, okay? And SQL Server, well, basically offloading the data to Hive and bringing that data set if you and when you need to. They're able to, once you go through that paper, you'll see the time to report on those particular data set and the amount of data they were reporting. It was essentially not practical enough for them to do it in SQL Server because they're mining the data. It's basically cloud paper. So if you do cloud and Microsoft and Hadoop, you will see they're on Google. So they're mining these social networks every few hours in a day and trying to mine through 15 billion records, and SQL Server was not able to handle that. So they put together the solution to offer this great query performance and provide kind of drill down for the customers, provide the rich level dashboards. And the other thing SQL Server Analytics Services offer you is inbuilt driver sets. So you can use OLEDB drivers and use Microsoft ODBC drivers, obviously available for free. Right? Okay. So we talked about how to put this together today, right? So you install Hadoop on Windows, you connect to your databases using SQL Scoop connectors, and then you use ODBC resources in your BI tools with authentication enabled on Hive Server 2, as well as plug into your SQL Server analytics services and do direct OLEDB over ODBC connection to your SQL Server, to Hive. What Microsoft did, they announced one more project called Hackathon in last September in the SQL Pass. So SQL Pass is a de facto standard for Microsoft for all the DBAs to come in, like we have Hadoop Summit, they have SQL Pass. So they announced this interoperability using a technology called Polybase. So Polybase is essentially it's an in-memory database type solution, whereas they'll try to bring in push-down analytics to the customer using T-SQL. So if you look at today how the data transfer happens, the data transfer happens two ways. One is using Hive to bring the data to your BI tools, or you're using Hive to bring that data to analytical services or SQL Server, or you're using Scoop connector to bring that data from Hive to your SQL Server and vice versa. So it's only limited options you have. So the other solutions, if you look at like Hadoop or Aster, they have their discovery platform where they can do a map reduce job on the larger data set. And we all know doing a map reduce job is more efficient than doing direct scoop or using a Hive query. So in the phase one of the Polybase, which is going to be it's not going to be a single query available, but what they're trying to do in phase one, they're going to put these pieces together. The Polybase will be available on SQL Server with Parallel Data Warehouse, and then you can essentially think of this way, the Hortonworks data platform Edge catalog will be plugged into the Polybase engine, whereas they can do the metadata layer. But in that phase one of the project, even though they understand where the tables are, the data transfer will still happen over Hive query or using Scoop connectors. And in the next step of the project, which is I think it's slated for end of the year, potentially process the data in place, which is what we mean by push-down analytics. So now you see a customer, an application, you have SQL-like interface, you have Polybase, and underneath you have either SQL Server or Hadoop. And the data is being archived from SQL Server or your SQL Parallel Data Warehouse into Hadoop for historical retention, or if the data set is large enough, the data flows the other way, right? You're doing ETL process on Hadoop, pushing that data for reporting into PDW. So the idea is let customer run SQL, and you don't need to know where the data set is. So if you say select star from blah, 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 you need to know where the data sits into Hadoop today. You don't. So with Polybase coming in, they'll be able to run those queries, and Polybase will be able to understand the metadata, understand the schema on the other data connectivity items you have, such as SQL Server as other data source or Hadoop as other data source. Now, rather than bringing in the data to PDW, you'll say, okay, go process this for me, run this MapReduce job, filter the data, and bring that data back into PDW, and then present it to a customer without you having to know, or without customer having to know where that data sits, right? So it's a transparent SQL execution engine. It's like Astra SQL MapReduce. So today, it's basically using SQL MapReduce job. You have to define a SQL-like statement. It'll look into Hortonworks Edge catalog. It'll say, okay, here's the metadata for that particular table you're doing. Bring that data in, do an in-memory join from other data sources, and present it to a customer. You'll be potentially be able to do the exact same thing on Microsoft when the Polybase is released in phase 2. In phase 1, the data transfer remains the same. Oh, cool. I'll give it to Rohit for the demo.
Okay. Thanks, Abhijit. What we'll do now is go through a demo of some of the integrations that, so additional integration that we hadn't talked about, but Excel, talking to HDFS, and pulling data out of Hadoop. And I'll talk to a use case here. So to paint the use case, we have log data, right? Very similar, regular Hadoop use case. You have log data that's being captured, and you want to explore it, understand what's there, and then you want to incorporate into your regular processing. So let's say I have log information coming in. I load into Hadoop, and I want to be able to explore it. I want to see what's there, see what columns, see what data is there. And then on top of that, I want to take that and now go to, instead of an exploration phase, go to actual ETL refinery phase, where I pull in product information, pull in user information from my OLTP system, SQL Server, and then run some transformations to join them together in Hadoop. And then from there, I use that. I get the output of that query, this refined, analyzed query, and I use Excel, some of the stuff that Abhijit was talking about, to create information, insights, charts, aggregate views, right? And I'll show you how we did that through a demo that we can start now. And so what I have here is I have a machine that has the HTTP 1.1 for Windows installed. So you can see it's in program and features, right? When you install Hadoop, it actually shows up here. And it's now a managed program on Windows. And apart from that, what we also have is so when you install HTTP, all the binary, all the source code, everything that you expect when you install Hadoop on Linux is installed and copied to the Windows file system. So this is on a single node right now. You can actually have this on multiple nodes. And you can have multiple nodes registered to services. And so if you look at the service pane, multiple of those nodes are running the services. Now, going back to a use case, right? We have raw log information. It comes in, it gets written to HDFS. And so if you look at the HDFS file system, we have logs file that's being generated by IIS or whatever your log management system is. Now I want to explore that. What I'll do is I'll go to Data Explorer, so the component, choose the option to go read off of HDFS. And what it's doing now is it's actually using Web HDFS, which is an API that we wrote to talk to Hadoop. And it looks at all the files that are available in HDFS. So through Excel, you are now interacting and exploring with your Hadoop file system. I say logs is what I care about. That's my raw log file. Click on it, it's going to load it, and it's going to start looking at the data. So it looks at the data, it's using Web HDFS to talk back and forth with Hadoop, so you can actually have this running on your client machine and going over this REST API to interact with what's living in your Hadoop cluster. This is the raw data. I now use Excel's schema management functionality to actually say it's a tab separated file, tell it how to handle some extra columns and some error reporting, and then go into the next step. What's doing now is it's talking through Web HDFS, talking through your Hadoop cluster, and it's going to take this raw information and help you organize it, help you explore it, help you figure out what columns are there. So what we see here now is it's a list of columns, right? Because all it sees is this raw file, but it knows the delimiter. It's now looking through. I can say stuff like, this first column in my exploration, I don't care about it. Let's get rid of it. I just want to focus on other columns. There's a timestamp column. I know it's a timestamp, so I'm going to organize and call it a timestamp. Through Excel, I'm interacting with my raw Hadoop data. Once you do that, you actually save it, and now you have this kind of information. You have an organized view of your raw log files, all in Excel. And so what I can do is I can filter. I can say, I care about, let's look at how these IP addresses are behaving over time. Let's look at one IP address. It'll then show me all the days that it came on, and so I can now see for this one IP address, I just had one date, one visit, and here's the URLs it hit. So you can start exploring your raw data. That's what we did with raw log files here as well, right? And then I talked about products and users, and we brought in from SQL Server OLTP, brought in product information, brought in user information, all into Excel. So Excel is your one tool you're using to manage this entire process, from explore to refine and analyze. And you can look through the different users that have available. This is what I'm going to run, and I ran as my transformation query. It's a SQL query, looks very familiar, right, to what you would write in any SQL product. And it's basically a Hive query. It's telling, here's the different tables that I have based on those raw files that you saw in Hive. And I want you to combine them and aggregate them in a certain manner. The result is a file that I then, through Data Explorer, load into Excel as well. This is the result. This is your last stage of an analysis and a result of all that scalable Hadoop cluster performance. And with that result, you can do some beautiful things, right? Now that you have it all in Excel, like Abhijit showed you, using the mapping API as part of PowerView, I'm actually showing this distribution of unique IP addresses hits across my different states. So the size of the circle is the size of the amount of unique visitors that I got in that state. You can see California, Texas, Pennsylvania, East Coast have some of the higher unique visitor counts for my product. And then I can also do other interesting things, like with this next chart, actually showing the over time how my unique visitor count maps to how many different products I sold in those days. So with PowerView, you can actually click on the day, and it's actually interacting with the data and showing you the count of unique visitors and the count of the different categories that were sold. So was it a broad spread of products? Was it a small spread of products? And how does that relate to my